Okay, I'm going to review your quiz with you. This was the quiz for the standard G.SRT 2, and we have discussed the scales that go along with this. So your first question, if you had 1B, was to state if the triangles in each pair are similar. If so, state how you know that they're similar, and and complete the similarity statement. So in this particular case, what we know is that we've got these two triangles here, and we have that these angles here are congruent to each other. That's what these arcs mean. So it looks, because we've got side, an included angle, and a side, that if these two triangles are similar, that they will be similar based on the side angle side similarity theorem. But we've talked many times on how you can't just assume that because side lengths are given that they are indeed proportional to each other. So you have to check it. And the way we're going to check this is we're going to say EF, which is our small side of our first triangle, divided by 66, which is the small side of the larger triangle, should equal 53 divided by 99, the larger sides, okay? And so if we have it set up in this manner, we can then cross multiply. And if we cross multiply, we have 36 times 99, and then 66 times 53. And what you'll see is that these products are not the same. One is 3,498, and that does not equal 3,564. So because these cross products are not the same, we can say that these two triangles are not similar. Okay, find the missing length. We are told, we are given very specific information that the triangles in each pair are similar. You're also given these similarity statements. So your first step should be to indicate what angles are congruent to each other, and they're given to you. We know that angle R is congruent to angle R because they're in the first location, or they're in corresponding locations here. We know that Q and M. So I know that these two angles here are congruent to each other. And then we know that P and L, because they're in the last location here. Okay, so once you have that, it's easy to see what sides should correspond with each other. So we've got between one arc and three arcs, this side length here of 143. Okay. And let's change this to a darker green. So we've got 143 here. And between the 1 and 3 arcs down here, we have 22. Okay, so those sides correspond to each other. Now, in our top triangle, triangle RQP, we've got that this side length here, RQ, is our unknown. And then down here, it would correspond to RM because we've got one arc and two arcs, and then one arc and two arcs. Now, without drawing in your arcs, it's harder to see what sides go together. Okay, so or our corresponding sides. So then I would cross multiply, and 143 times 14 is 2002, and that equals 22 times x. So that equals 22x, and then I would divide both sides by 22 to get x equals 91. Okay. The next question here, find the missing length indicated. Leave your answer in simplest radical form. We are looking for this side length here. We call this the altitude. So this is using the altitude theorem here, which says that we've got these similar triangles. So we've got this one similar triangle that looks like this, and this is our x, and this is 64. And what we know is 100 minus 64 is 36, so this little piece down here is going to be 36 because we know 64 plus 36 must equal 100. So we've got the other triangle that has 36 and x, so these are now in corresponding locations. So when I set up to find x, I'm going to say x divided by 64 is equal to 36 divided by x. So I have x squared is equal to 2,304. And if we take the square root of both sides, we get x equals 48. Okay. Question number 4. Again, we're given that this side length here is 10, and we know that this portion is 4, so this portion here is going to be 6. We're going to say our question mark is equal to x, and this particular triangle is using the angle bisector theorem. Okay, so we know that this angle here has been bisected because we've got these two congruent angles given here. So this is an angle bisector theorem, and that gives us the relationship between sides of triangles and the part of the triangle that was intersected. Okay, so when we set up our proportion here, we can say that this side divided by that part, so 8 divided by 4, is equal to this side here, which is our unknown of x, divided by this part, 6. And now if we cross multiply, we have 6 times 8 is equal to 4 times x. So we have 48 is equal to 4x. Divide both sides by 4, and we get that x equals 12. Okay. Problem number 5 is using the triangle proportionality theorem. Okay, we're told that these two lines here are parallel because of this notation. So what we know is that these sides here are proportional to each other. Well, if this piece is 8 in total of the length is x plus 8, we can say that this piece here must be x, right? That's our unknown. We know it must be x. So if I set up my proportion, I can set this up in multiple ways, but one way is just to start on each side and go towards the vertex there. So we could say 3 divided by 4 is equal to x divided by 8. That's one potential setup, and when we do that, we have 3 times 8, which is 24, is equal to 4 times x, and then divide both sides by 4, and we would get x equals 6. Okay, that is one method that will work. Another would be for you to say, go the other way. And 4, you could say 4 over 8, because these two pieces correspond to each other in that manner, and then these two in this. So we can say 4 over 8 should equal 3 over x. And guess what? You get the same result. We get 4x equals 24, so x equals 6. So if you set up the proportion correctly, you're going to get that x equals 6. Okay, and then question number 6. We can see that this is a right triangle because of this 90-degree angle. So we should be using that Pythagorean theorem. And the Pythagorean theorem says a squared plus b squared equals c squared. Okay, well, we know that c is always the hypotenuse. And honestly, it doesn't matter which one is a and which one is b, as long as you're not confusing c as one of those two legs. So c is always the hypotenuse. The other two you can notate however you wish. So if I let this be a and this be b, I would have 9 squared plus x squared equals 15 squared. So 81 plus x squared equals 225. Subtract 81 from each side, and I get x squared equals 144. Take the square root of both sides, I get x equals 12. You take the square root of both sides, and you get x equals 12. Okay, and that is quiz 1B.